Hi, my name is Jared Rivera. This is Nicole Orndorff, Vincent Zhang, and our fourth team member is Mohammed Elisa, and we're Newton's BRG. We'll be going over what we found in design phase 2. So with project management, we've adjusted our Gantt chart according to how our project was going. So we actually had to shorten task 3, which is intellectual property research, by about 7 days because it didn't take long to research all the patents. In addition, we've had to prolong task 5, concept testing, because it took a long time to overall test the project with cheap prototypes. And our project is going according to schedule.
And so there are about 5 patents that inspired the team on the final design. So firstly, the team decided to find a similar product. It's a kinematic educational device that related to our final design. And from that one, the team decided to dissect it to different components, which are like a roller coaster and domino game, and also a spring-mounted bumper, and also an electromagnetic motor, which are all those things like a motor and a spring, and also dominoes at the end, and also loops. So combine all of those to assimilate to our final design. So also the team tested our concept by a survey to 6 people, and 50% of the participants said they want to they learn science from school, which is pretty dull, and the majority of them said they want to explore a more interesting way to learn science. This says by joining a lecture program, and 83% of them said maybe to purchase our product when we introduce the BRG program to them. But however, only when the price range to 0 to 20, they might willing to purchase that. Otherwise, they will not. And finally, we have to mention that 50% of them says we have to add the attention grabber in order to make intrigues them more.
So using a concept combination table, our team came up with 5 different potential solutions for our final product. As you can see right here, for concept 1, a spring to a loop to a ramp to friction to dominoes and then to an Arduino sensor or switch. For concept 2, a spring to a frictional surface to a rebound to an Arduino sensor. For concept 3, a tunnel to a free fall to dominoes to an Arduino sensor. For concept 4, a ramp to a bank curve to an inelastic collision to an Arduino sensor. And then for concept 5, a ramp to a projectile motion to dominoes to an Arduino switch. And concept 1, 2, 3, 4, and 5 will be referred to as such for the later half of this project. The first matrix was a concept screening matrix, and this helped us eliminate some options for our 5 initial considerations. As you can see right here, our team decided that maximizing educational concepts and also low costs were the most important objectives for our final design. All of our concepts, the ones that passed through the matrix, were concept 1, concept 2, and concept 5. The other 2 were eliminated because they didn't fit all the criteria we were looking for in our final design. The second matrix we did was a concept scoring matrix, and this helped us decide our final solution for our product. As you can see again, low cost and maximizes educational concepts were weighted 20% each because we felt those were the most important. We had a reference, which was concept 4, because it was very a standard concept, and we compared each of these 3 concepts to concept 4. And concept 1 was the highest scoring of all 3. Therefore, that was the concept we chose for our final product. Here's a drawing of what our concept 1 will look like. We'll have a spring to a loop to a ramp to a frictional surface to dominoes and then to an Arduino sensor.
Okay, so here's our product decomposition. Our final concept, which is concept 1, it can be broken up into several sub-concepts or sub-problems stemming from the original inputs, which are the ping pong ball, the calculations, and the potential energy from the spring. As the ping pong ball goes through the BRG, it'll go through obstacle 1, 2, 3, 4, 5, and eventually the ping pong ball will come out and the flag will be raised to show that you've completed the entire project. Calculations must be done to determine how these objects or how these obstacles are oriented, and these will be adjusted according to error. This is where our educational value will come out. The potential energy from the spring will be the initial energy input, and this will go back and forth between potential and kinetic energy as it goes through the actual obstacle course. It will start with potential energy, then go to kinetic, then it will have a mixture of kinetic and potential as it goes through the loop and the ramp. Finally, energy is lost due to friction, and finally kinetic energy is outputted as the dominoes are being hit. So we also analyze the potential failures and effects of obstacle 1, and we determine how to address the issue of inadequate force from the spring. This is highlighted right here. So if the spring does not have adequate force, it will not impart the correct force to the ball, and therefore the ball will not make it through the entire obstacle course. This will be due to the fact that the spring constant is too small, and we decided that the best way to combat this is to have the manufacturer inspect each spring and through trial and error figure out what the actual spring constant needs to be. Given that the spring constant is not high enough, we will upgrade to a stronger spring.
So we have an economic proposal to VTEPs. So we have a 3-year proposal with a one lump sum investment of $25,000. This $25,000 will go into things like materials and machines and anything in the startup costs. And we will start repaying in Q5, so we have 1 year to dedicate our funds to production needs. And after that, we will have quarterly annuities of about $4,400 for the remaining 8 quarters. And after that, the VTEPs would have made around $10,000, which is a 41% return on investment and a 12% APR.
So in conclusion, we have successfully completed tasks 1 through 6 on our Gantt chart, and we will now move on to tasks 7 and 8, as we've shown with the remainder of our Gantt chart. Thank you for watching. This concludes our DP2 presentation.